All right, this is 2-3, which is a factoring section. You're supposed to establish a relationship between factors and x-intercepts and zeros and roots and all those wonderful words. But the first couple are just factoring. I'm going to do number 2. And when I look at number 2, I think about what both terms have in common. This is not a trinomial. So I'm just going to think about what they have in common. They both possess at least a 3x. Because 9x squared is divisible by 3x, because 3x times 3x is 9x squared. And if I divide a negative 3x by 3x, I find that I have a negative 1, so minus 1. You know, think about the distributive property. Is this the same thing as it was? And it is, so it's still equal to 0. Kick in that ZPP, 3x is 0, divide by 3. Anything, 0 divided by anything, with the exception of 0, is 0. And the other guy, 3x minus 1, is a nothing. That's a two-stepper. Add 1 to both sides. Divide by 3, and x is a third. Let's look at 5. On 5, I say you might shift everything right, because if you do that, the a squared variable becomes positive. In fact, they all become positive. And now let's see if it factors. It does. It's going to take a 3a and a 2a to generate my 6a squared, and factors of 25 are 5 and 5. And, I guess, and I'm going to check, the outside would make 15a, and the inside would make 10a, and 10 and 15 is going to be that positive 25, still equal to 0, so now I kick it with the ZPP property. 3a plus 5 is a 0, or 2a plus 5 is a 0. And you ought to be able to do these in your head. I mean, make it negative, divide by 3, negative 5 thirds, or negative 5 halves. One of the two. Those are your zeros, your roots, your x-intercepts. Let's see, let's do 7. 16y squared plus 60y. If we're going to use a zero product property, we have to equal 0. Get as good a time as any to do it. And what can I do to this one to make it easier? Everything is divisible by at least 4. So I'm going to pull a 4 out. That'll make 4y squared plus 15y minus 25. And this just makes it easier to do the next step of factoring. That's why it's done. It's not mandatory. It's 100% optional. It just makes things quicker. I believe it's going to take a 4y and a y to generate what I need. And I think this will do it. The outside is going to make negative 20. If I take these two and these two, I'm going to get negative 20y. And if I add 5y, sorry, I did that backwards. That one's plus. This one's minus. So I have a positive 20y, take away 5y in the middle. And that's positive 20y, take away 5y in the middle, which is my positive 15. And then I just use the ZPP. I'll have a 4y minus a 5 equal to 0. Add 5 divided by 4, y is 5 quarters. And then I have y plus 5 is 0. Subtract 5, y is negative 5. All right, moving on to the next step here. We're supposed to write the factored form of a quadratic given its zeros and an a value, and then write the thing in S2D form. The hardest one up here is probably 11, so that's the one I'll do. You have a form, I call it the general intercept form, and that's what we're using here. It's y equals a times x minus p times x minus q, dot, 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 if you have more factors or more intercepts, okay? Where p and q are your x-intercepts. So, for all intents and purposes, that guy's p and this guy's q. And, of course, there's a right there in the beginning. So if I plug stuff in, I would have y equals a times, I'm actually going to do this one first, x minus a third. Oops, let me go back. A was -3, wasn't it? -3 times x minus a third, and then times x minus 2. Now, the reason I put the second one first is because I was thinking ahead. I'm going to do the distributive property. I'm going to leave the negativity outside. 3 times x is 3x, and then the 3's cancel, -1. I left the negativity outside. I didn't move it inside. And then x minus 2. So there is a good factored form. Give me a second. Now we're supposed to put this thing in STD form. And to put this thing in STD form, which is, if you forgot, because you're kids and you don't like math, ax squared plus bx plus c, we're just going to FOIL. I'm going to leave that negative symbol out there for a minute. 3x times x is 3x squared. 3x times -2 minus 6x. -1 times x minus x. And then plus 2. What we actually have in here is a -7x, right? Now we're going to distribute the negative. Y equals -3x squared plus 7x minus 2. So these aren't too hard to do. I don't think they're hard to do. I don't think much of it is. There's the fill in the blanks, and these are going to throw you off a little bit because I hadn't asked you anything like this, and it wasn't in your notes. But we have a quadratic that has an x-intercept at -1/2 and 0. I'm just going to draw something. Maybe that'll help you understand what's going on. -1/2 and 2. I don't know what it looks like, but this is an idea. That fits the definition. Then f of blank is blank and f of blank is blank. So if I let x be -1/2, I have a y value of 0. And if I let x be 2, I also have a y value of 0. It's just function notation, is all it is. By the way, these are the same thing. X-intercepts and roots are the same thing. All right. So using more of these, if f of 1/2 is 0 and f of -3 is 0, then where do I have x-intercepts? Well, I have an x-intercept when x is 1/2, don't I? Because this is the y value, this is x, this is y. So then I have an x-intercept at 1/2 comma 0 and at -3 comma 0. That's how hard this thing is. All right, one of the trigonometry ones. And pay attention to where these things lie. Quadrant 2, quadrant 4. I'm going to do the quadrant 4 one. You got to understand good old SOHCAHTOA. I'm told that the sine is -3/7. The sine ratio is opposite over hypotenuse, so I have a lineup. Trigonometry literally means triangle geometry. So you're going to just draw a triangle. That's what you're going to do. And it's supposed to be in quadrant 4. If you don't remember your quadrants 1, 2, 3, 4, shame on you, by the way, if you don't remember that. Shame, shame, shame. I'm going to draw a triangle in quadrant 4. It's going to be a right triangle. The angle is always in the corner by the origin. And then I'm going to set it up. Opposite is a -3, which makes sense because this triangle has fallen. And the hypotenuse is 7. Anyways, I want cosine and tangent, which means I have to know this side right here, this adjacent side. I'm just going to call it x. I'm going to do a little Pythagorean theorem. X squared plus a negative 3 squared must be a 7 squared. 3 squared is 9. 7 squared is 49. I'm going to take away 9, and I'm going to get 40. So x is the root of 40, and I'm going to simplify. Root 40 is root 4 times root 10, which is 2 root 10. So x is 2 roots of 10. And then I'm just going to do what they asked me to do. They want me to know cosine. The cosine of an angle is adjacent over hypotenuse, because you can spell SOHCAHTOA. And adjacent is a 2 root of 10, and the hypotenuse is 7. The tangent of an angle is the opposite side over the adjacent side from SOHCAHTOA. And opposite is a negative 3, and the adjacent side is 2 root 10. And you had Cantrell last year, you know you were not supposed to leave things like this. You need to, this is called rationalizing the denominator. You need to multiply the top and bottom by root 10 over root 10. So what we have up top, negative 3 root 10, because negative 3 times root 10 is negative 3 root 10. Down low, when you multiply a root of 10 by a root of 10, you get 10. A radical times itself is the same thing as squaring, and squaring counteracts the square root. So the bottom just becomes 10. I'm not the one who created that rule about doing that, so don't hate me. Don't hate the player. You hate the game. Let's see here. I'll do 19. Why not? They both 18 and 19 are the same thing. 19 just has a graph. Find the general intercept form, the standard form, and the vertex form of the following thing. All right, so let's start with general intercept form. First, let's put some points on here. This is 2, 0. This is negative 3.50. And this is 0, negative 14. So let's start with general intercept form, which is y equals a times x minus p times x minus q. You know, there's q, there's p. So part 1 here would be y equals a times x plus 3 halves, because we change signs when we enter leave parentheses. And then we have x minus 2. This is how I figure out a, because I have an x and a y I can plug in. Negative 14 equals a times 0 plus 3 halves. And then 0 minus 2. So I end up with 3.5 times a negative 2, which is a negative 7. I divide out the negative 7, and I get an a value of 2. So part 1, I'm stuck at 2 times x plus 3 halves, which I'm going to clean up, times x minus 2. I'm going to distribute my 2 to make it look prettier. I'll have 2x plus 7 and x minus a 2. Sorry, my wife sent me a text what my kids are doing. All right, so we've done part 1, standard form, part 2. Take this thing and FOIL. It's not hard, it's not even tedious. 2x squared minus 4x plus 7x minus 14, clean it up, 2x squared, what, minus plus 3x minus 14. All right, the last part is vertex form. I need some room here. Part 3, we want y equals a times x minus h quantity squared plus k. I do know that a is 2, right? I put a 2 there. And I have to find the rest of it. So h is found by doing opposite b over 2a. So negative 3 over 2. times 2, which is negative 3/4. So I'd have x plus 3/4 because I have to change sign when I enter. All right. And I got to find k. I find k by taking this value and plugging it in. That'd be 2 times negative 3/4 quantity squared plus 3 times negative 3/4, and then take away 14. So if I square this, I have 9/16. Don't ask me why I'm doing this in my head or doing this by hand. Take away 9/4, take away 14. Let's see here. Let's make this all about 16ths. This becomes 18/16 because I double 2 times. This piece right here, I don't know why it's trying to pull that up. If I multiply that by 4, I multiply that by 4. So that's going to be take away 36/16. And if I multiply this guy by 4, I have what, 64? No, tired. 76. And it's also a takeaway. So that's what I'm looking at. And then I just do the math, right? And what do I end up with? 18 minus 36 is negative 18. Negative 18 and 76. I feel like that's negative 94/16, which reduces quite a bit, I feel like. Negative 47/8, maybe. That seems right. Negative 47/8. Not plus here. Minus 47/8. You should probably check me on that one. I don't think it's wrong though. I'm just not going to pull up a calculator. Let's see here. That's the TP example. I'm going to do a TP example. I'm going to let you guys try to figure out Johnny's fate. A juvenile domestic terrorist spots a tree in Milbrath-Math's yard. The tree is about 23 feet tall. The terrorist stands 14 feet from the center of the tree, throwing the roll overhead from a height of 6 foot and clears the tree by 3 foot. The roll lands exactly 16 foot from the tree's center on the opposite side. So here's your terrorist. I need to draw him a little farther over here. The roll of toilet paper has to be on the y-axis. And the toilet paper is thrown from a height of 6 feet, so the coordinates here are 6. We have a tree. There's my tree. The toilet paper goes over the tree and it lands on the ground. Now, the kid was exactly 14 foot from the center of the tree, so that would make the center of the tree 14, 0. And it landed exactly 14 feet from the tree center on the other side, so that would make this 28, 0. I clear the tree by 3 feet. It's a 23 foot tall tree, so this has to be 1426. All right, moving forward. We're going to write the vertex form. And you actually have the vertex of your parabola to some degree. This is where it gets kind of interesting because that may or may not actually be the vertex of the parabola. But anyways, we're going to go with it as good as we can get. Yeah, these are not perfect at all, are they perfect? But it's good enough for instructional purposes. If you're watching this and you understand math, you do realize this is not the vertex. The vertex is actually somewhere over here. If I threw it from 0 feet, it would be. The reality is, if things are perfect, there's some point here that's 28.6. But we don't have that. I apparently need to recreate some of these problems so they make more sense. Anyways, we're going to treat that as a vertex. That's our H and K. So y is a times x minus 14, quantity squared, plus 26. And I need to find the a value, and that's where this point right here comes in, my x and my y. 6 equals a times x minus 14, quantity squared, plus 26. And I'm making mistakes here because my wife's trying to talk to me at the same time. She doesn't understand that I work. I'm not available. The x value is 0. And then we do some math, like what's 14 squared? I feel like it's 196. Seems right. We're going to take away 26 from 6. That's going to give us negative 20 equals a times 196. We're going to divide that 196 out. And my a value is going to be 10 over, well, I'm out of it, 98. So negative 5 over 49. Negative 5 over 49. And now I have an equation. So part A is y equals negative 5/49 of x minus 14 quantity squared plus 26. Part B is to put it in standard form. All you gotta do is write the inside twice. Several of you ought to be able to do this properly in your head. Then you just double the negative 14 minus 28x. 14 times 14 is 196, and then you have x squared. But don't forget about the negative 5/49 part. That's what makes this one fun. You have to distribute the negative 5/49. And this is where it gets fun. We'll have negative 5/49 of x squared plus what, 140/49 of x. And then we have this number that we have to add 26 to. And I'm not wanting to do that in my head. So what do I have here? I have negative 5/49 times 196. Oh, wow, it was negative 20. Isn't that cool? Of course it was. Plus 26, because you're going to get 6 back. I should have thought about that. Plus 6. See that 6? See that 6? They had to line up now, didn't they? There you go. Easy peasy Japanesey. And I'm going to let you decide what happens to Johnny, because I'm tired and I don't want to do anymore. So do what you want with Johnny. Do you like him or not?